So yeah, I mean, I think that was everything that we had on the schedule. Should we go to open discussion now? You guys want to go to open discussion?
Sure. If what's his name? The material scientist dude, is he here?
Oh, yeah, Thomas.
Yeah, Thomas. If he's here, we can talk.
Well, let me see. No, it looks like he might be back. I think he might have had something else going on. Yeah, no, this has been an interesting conference. This has been a really interesting conference. I'm really excited. I'm excited that Michael was able to present his whole thing, and I was really surprised by Frank actually because he'd just done. I didn't know there was that much data available. You know, he just kept pulling stuff out, and I was like, "Wow, that's amazing." So,
well, he put together the reports. He's the one who should know.
yeah.
Also, we should mention, guys, we're on Wikipedia. This conference officially made it to Wikipedia, and we were mentioned in Popular Mechanics.
Yeah. Yeah, no, that's exciting. That's exciting. And well, and who knows if we keep covering the UAP stuff, you know, we may get a couple of surprise mentions here in the near future.
That could very well be. Jeremiah, do you have any anything to show?
You know what? Let me see it. Yeah, he's here. Let me ask him to unmute.
There we go. Yeah, it's still set by default for everybody to be auto muted. So just an FYI, if you want people to be able to freely unmute themselves, you're still set to so they can't. I don't have anything set to present. I don't have the info or the picture is set up, but I can tell you I've been working on a few experiments that were mainly just disqualifiers. So we found out what was ions. Again, more ions. But interesting phenomena where we can produce very large quantities of ions very quickly and produce sort of a percussive pulse that is able to push a soda can pretty hard, actually, almost like it's been punched. So that was fun. We just had to figure out what was going on there because we were like, oh, this is an interesting phenomena. I wonder exactly what it is. The interesting thing that I was looking at, and recently we went back over the Bonson lab videos, and we were looking at some of the diagrams there, and they were so critical to look at those diagrams because they're only shown in those videos for maybe 1 or 2 seconds, but some of those diagrams are critical, and one of them is interesting. There's a light bulb with a heated filament, 2 long lead wires going down to a battery power supply, and then that's hooked up to his pulse power supply, and that light bulb is taking the place of the small electrode on the underside of the parabolic reflector. So I will show you real quick, and I can bring it over. So this was just the basic little test to see. I finally found a good quality vacuum bulb. It's a genuine vacuum bulb. So this is not an argon filled or gas filled, and it's interesting because it doesn't produce any plasma or anything. The only thing that happens when you activate high voltage is that the filament on the inside, which probably you can barely see, but that filament will pull towards the anode here, which is then just going through a rectifier, a single stage rectifier. So no smoothing capacitance, simple pulse transformer. It fires 10 times a second, 20,000 volt pulses with a 1 millisecond rise in fall time. Primarily asymmetrical on the positive side, and it also helps that it's rectified, so no reverse flow. But this is a non-heated cathode system, and this is just to sort of prove the idea that it doesn't necessarily produce force or much force at all without that heated cathode, because the electron emission won't happen at 20,000 volts in this kind of a vacuum capacitor, where the filament is one of the 2 elements of the capacitor, unless there is some current flowing through that filament. So we're going to be checking to see if Brown had anything there, and there are several theories that state electron momentum within a system where you have electrons in one part of that system at the emission or the emitter traveling at a low velocity, and when they strike the collector, or strike, in this case, the glass plate that's in the way of the collector, they'll have a high velocity. The relativistic difference between their velocity and the consequent forces that the system experiences in independent parts of itself are theoretically different, according to 2 different papers that we've recently gone through. So we're going to go and check to see if those papers have any validity and trace it back to Brown if we can. That's the recent experiment about vacuum bulbs, and it's one that we haven't done before, so we're pretty excited about it. We've tried it before with a non-vacuum bulb. It doesn't work with argon bulbs, I can tell you that. We already found that out at the Falcon Space Lab a couple months back. But that's all I have for now, folks. I will have more next time. Hey, go ahead, Ron, Kita. You got to unmute, though. You have to unmute again. Not quite yet, Ron. You're still muted.
What I wanted to mention, it may not be related, It's just through a connection. I've been mailing out a lot of, did you ever hear of Morton Spears? Capacitive theory of gravity?
No,
Morton.
I haven't.
Okay.
Morton, S-P-E-R-S?
Okay, it's Morton, M-O-R-T-O-N. Last name is Spears, S-P-E-A-R-S. It's called CTG for capacitive theory of gravity. And
I'm searching it now.
he is an MIT graduate from 1943.
I will familiarize myself with his theory. I've not heard of it yet, but this is a very interesting exploration. Thanks.
Yeah, okay, that's about all. So I just, wherever I can, I missed the earlier part of what Mark was doing. I didn't know. I'll come back and watch it on the YouTube. So Mark's discussion of, I was out having lunch. I'll come back and catch Mark later. Okay, thank you.
Yeah. Thanks for the information, Ron. I appreciate it. It's always good to get another direction to search for and learn things from. Thanks.
Jeremiah, let me jump in really quick. So unless Zoom is hopefully Zoom is doing okay. I have it set so it's allow participants to unmute themselves. So by default, everybody is muted, but I set that so that you can unmute yourself. So I know Will has his hand raised. Will, do you want to give it a shot? Try and unmute yourself and jump in, sir. I started locking that during presentations, but it's unlocked now. So if it's not going to let you do it. Okay. Maybe I'll quit. Maybe I'll quit using that then. Okay. If I click ask to unmute, does that now you can do it?
Yeah, it works.
Okay. So something must be stuck in Zoom because it says, let me try and set it and then unset it again. Okay. Anyhow, I'm sorry. Well, go ahead, Will.
Okay, yeah, I wanted to say sorry, who's the guy who just talked? The
Oh, Todd. And I'm not sure if Todd is still here. Todd was having some, I think all of us are struggling with hay fever and stuff like that today. So.
Yeah, the one they had the experiment, right? That's Todd?
Yeah, there's
with the light bulb.
Oh, Jeremiah. Okay. I'm clicking.
Yeah. So anyway, I just wanted to say to him that actually what he has in his hand is an X-ray generator.
Indeed, it is. Yes, we're quite aware. We don't sit next to the experiment when it runs.
Yeah, I actually made these in junior high for my own experiments back in the 70s. So it's actually quite an old idea. But be careful because those things do generate X-rays, and that can be very dangerous for you.
Yeah, I had well considered it, and I set these things up where they're remotely triggered. So what I didn't show you guys was that on that system, in fact, with all the boards that I'm building now, all the small battery powered PSUs, they all have photo triggers on them, so I can remotely activate them from 20 feet away, no problem, with a laser or any other device. So it's quite convenient, and that's how we operate the experiments. It also helps too because I don't want to be near it. My body generates heat, and that affects the experiment. It's a very sensitive scale. It basically rests on razor blade edges sitting on aluminum beads so that one doesn't wear out, the other.
I'm sorry. I didn't mean to. Okay. You know what? I got it set now. I think I got it set. It wasn't sticking for some reason. Mark, do you want to give it a try? Go for it.
Yeah, it's working now. Okay, good.
Okay.
Right.
I'm sorry. I'm sorry about that.
Good.
So on the X-ray generators, I don't think 20 feet away is good enough if you don't have a shielded room. I work with X-rays all the time, and X-rays have a very good range effect. So just be very careful.
Would you consider to still be a danger at half a watt?
Between you and the X-rays.
Do you have lead shielding?
Gain X-rays.
Yeah, I do. We do.
Do you have lead shielding, Jeremiah?
Yeah, I have access to it. What I'm asking is, would half a watt at 20 feet away realistically be a serious danger at 20 kV, for example?
Yeah.
X-rays is X-ray, gamma ray, these types of all radiation is a time effect. So it's like if if you go to take your X-ray, most hospitals won't let you take more than 2 a month because you're already close to the dose range. Now, of course, these are much bigger than what you're using, but if you're spending hours with it.
Oh no, it's normally about maybe 30 seconds to 60 seconds per test.
Yeah, but it's the same thing as what you get when you go to the hospital. So
well, luckily we just started playing with those, so I probably will throw up a little lead shielding cage then, and it'll be good to run inside of a Faraday cage anyway. So I'll just build the Faraday cage out of lead and just call it a day, 2 in 1. That sounds like a good idea.
It's a good idea. So, but as always, if you're working with X-rays, it's good to have an X-ray badge.
Yeah.
Looks like Glenn, is that your hand up?
Yeah. Or you can get a radiation meter. Like I have this one right here that I bought. It's called
Mark's got a bunch of them too over there in the Falcon Space Lab that I've had a chance to use. Actually, I think he's got one almost identical to that, don't you, Mark?
We have that right over here. I actually have a couple different radiation meters.
Right. So yeah, the reason I got this GMC 600 is it's the only one of them that I could find that measures alpha. You need to be able to measure alpha. Most of them just do gamma and betas. So, but so X-rays will show up as a gamma. It should show up on your meter. Okay. And it's good to have the meter. It's good to have it connected up so that it's hooked up to your computer, so you have a record. Okay, so that you can determine your dosage.
I think I'm going to do that.
Records are very important when you're working with X-rays. Sorry, I'm a qualified tech, so I had to go to school for all this. So I just try to pass on my knowledge to you, help you out.
Good news is I only have about 5 minutes of operation with that thing at a distance. And it's only a 20 kV and it's a non-heated filament, which basically means there's pretty much no current flow. It's probably in the microamps.
20 kV is pretty.
But luckily I haven't been exposed much, so I have time to do things a little differently then. Thank you, thank you very much.
So I had this job where I worked with a small linear accelerator that was used as a medical device to treat brain tumors. And they had a stereographic X-ray imager where they had these two-dimensional, they're about a meter square. And then they had 2 X-ray sources up above, and then they would make a stereographic image of the person. Okay. And those were all 20 kV. And this setup was in a bunker. It had 3-foot thick concrete walls and a big giant door, like literally like a bunker. That's what they call it was. And so that's the kind of shielding you need when you're doing this stuff. So, I mean, it's just a safety thing for your well-being.
Fortunately, materials are better today. So, and we know a lot more about X-rays, but 20 kV is a very excited X-ray.
It also depends on the current and the total wattage. So he was mentioning it was less than half a watt. I can't imagine.
Doesn't need it much. So 20 kV is pretty good X-ray. They have hard X-rays, you got soft X-rays.
It's not giving you any X-ray. You need current.
You have to worry about secondary radiation too.
We generate X-rays with you say like 50 kV at 2 milliamps. That can, in time,
That's 10 watts.
Can hurt you.
That's 10 watts. He's doing half a watt, which is 1/20th of that.
Yeah, well, cell phones use less, and some people
Microwatts.
Green tubers. So,
but that's not ionizing radiation.
yeah, exactly. It's not ionizing. But ionizing radiation is the worst of all of it. So fortunately, I don't believe that that's a problem. But like I said, it's a time issue. So the more time you spend with it, the more risk you have. It's really a time issue.
Yeah, I mean, to be honest, X-rays are concerning, but there's a lot more dangerous things in these labs than the X-rays emitted from these little experiments. And Jeremiah can attest to that. We have basically a lightning machine, a Marx generator that can pulse almost 1 million volts, and yeah, that'll hurt you a lot more than some X-rays.
Oh, sorry. Let me jump in really quick. Michael, while you're back on the call, because I know you had to leave for a bit, do you have a bio photo that you could send me to put up on the website? Because we put one up for each of our presenters, and so I don't have a bio photo for you.
Oh, geez. Yeah, I'll have to find it.
Oh, okay. Okay.
And I'm on my computer right now. So I just had to take a picture for an ID or something for my archaeology.
Yeah, no, that'd be perfect.
I'll just send you that.
Whatever you feel comfortable with. And sorry for interrupting, guys.
Well, sorry.
Tony Robertson said he wanted to join in the conversation. You're unmuted, Tony. Can you hear us?
Yeah, I wanted to first mention that secondary radiation through lead can be worse than the first radiation. I recommend you use at least a 1/2 inch instead of a 1/4 inch if you use lead shielding. Also want to ask you if what size the bed on your 3D printer was.
Oh, it's 310 by 310 and 345 millimeters in height. So it's basically like a foot cube.
Yeah, I think I built a 1 foot cube one. I think it's about 330 by 330 millimeters. Your piece that you did that was kind of bent. Are you using the glue on your table?
No, the table has a piece of basically it's a magnetic plate, and then there's a piece of spring steel, and on top of that is like a plastic layer, and it prints on that, and then you can pull the entire sheet off the magnetic tray, bend it, and all your 3D prints pop right off.
Yeah, it looked like it was some kind of G10, or they call it R4 or something. But I do that too. I use about a 1/4 inch, a 1/16 inch G10 where I can take off and bend it if I have to. But I still use the glue sticks, because I do get that what you have happen sometimes. Sometimes it even happens with glue stick, but not very often. So I recommend it. Just make sure you do light glue sticks, and the glue stick needs to have latex in it, or because there are some glue sticks out there that don't have that in it and don't work. Also want to let you know that I have a machine to do circuit boards, where I cut the circuit boards with the pointy pin type of thing. If you need any circuit boards, give me a holler. And I've printed circuit boards with surface mount stuff on it too, so I can get pretty fine cuts. I also have learned how to etch the boards with the vinegar and hydrogen peroxide and salt. That works very well. It's a cheap way to etch all the other copper off you don't need.
What kind of resist do you use to make your circuit board? What do you put on it to keep it from etching the parts that you don't want to etch?
I sort of kind of bolt the cladded board down to a plate that moves. I don't know what you mean.
Well, in the semiconductor industry, how they make a circuit is they take a semiconductor and then they spray this stuff on it. It's called photoresist.
I don't use that. I just cut the board with a little sharp cutting tool.
Oh, I see.
Guys, we have Wayne Ojala here. He has a demonstration he wants to show us live.
Cool.
He has to run.
Yeah, just real quickly, you guys are talking about the soda can repulsion test. I'll just do it quickly here. It's pretty cool.
Can we pin that full screen, Tim?
Yeah, let me find Wayne here. Let me see. Spotlight for everyone. How's that work? No. And did we lose him? There we go.
There we go. Oh, interesting setup now. That's a change up from last time.
Yeah, it's just another.
So
another...
Wayne, can you explain this a little bit? The screws are kind of interesting. What made you go with the screws? This is kind of a cool.
A little more dangerous. This is a neomagnet. So I was thinking, you know, the magnetic field causes ions to move in a curved path. So I thought it might constrain the column of the ions coming off this thing a little better. So yeah, I don't know if it actually helps too much, but I'm just impressed with the amount of force I get off this. It's pretty cool.
So that's a aluminum can, right?
Yeah, it's a pop can, and these are just, yeah, so the ions are going to be coming off these screw points here.
The point being, aluminum is a non-magnetic metal.
Correct.
Have you tried it with a jar, with a piece of glass?
I tried it with a little plastic bucket, and it pushes the bucket away, so it's basically repulsive on everything I've tried.
Have you tried taking the two wires and switching them? And seeing
polarity doesn't matter. It's always repulsive.
Oh, interesting.
It does. I can shield it though. Like if I put a little piece of plastic.
So Wayne, if I could jump in,
yeah.
The pop can, it looks like it's hanging from a string, right?
Yeah, it's just hanging from a little piece of thread.
Okay. And so it's just here. Oh, I get it. So you're basically just pushing it away. So you've just got but it's not a high voltage. It's a magnetic field that's coming out, right?
No, this is high voltage. Is probably 60, 70 kV.
Okay.
It's a multiplier here.
Oh,
coming out of here. So
okay, just be careful. Be careful.
Yeah, I'm careful.
It's hard to do this. How much current we talking there? A micro amp, maybe?
Oh, I have no idea. I mean, I'm using this neon sign transformer here. So, what does that say? 1 to 4.
Yeah. Those. And you're doing a multiplier, but
you're a 50 watt. So yeah, that's not very much current. So
then there's a lot of leakage here too. I mean,
yeah.
So yeah, but it's not really about current. It seems to be about the rise time of the potential.
So what happens when you put the insulator in between the two?
It's hard to do with just two hands, but I'll try to here.
Don't get a shock.
I'll try. Oh, it actually works. Last time I tried putting this barrier, it just it didn't repel at all.
Okay, so now can you move the barrier closer to the can? So increase the distance so we can see if the field strength.
Yeah.
See, it changes the field strength the farther away you get, correct? Looks like it's sticking to the plastic. Is that true?
I need a lab assistant here.
Oh, yeah, it'll get a surface charge. Yeah, lifters had that problem too. You get that surface charge if it gets too close.
Yeah, like it sticks to the plastic here.
Yeah, that's a surface charge. You get that. Yeah, we had the problem. Lifters won't take off if they're flush on the table because of the surface charge.
Right.
Yeah, I mean, I'm still learning about this ion, these properties of ions. It's
and there
he is. He's just
yeah. And when you're working with high voltage and ions, you get so many messy things. Like you'll get like with computer equipment and electronics and stuff, a lot of that stuff will die early because ions will actually climb up the ground wire into electronics, right? Because the voltage is high enough.
Do testing for that. It's they call it TUV testing, where you do what's called radiative emissions, where you take a spectrum analyzer and an antenna, and you measure all the radiation coming off your instrument. And then there's another one called conductive immunity, where you go and instead of you're trying to inject signal into the ground, okay, and it has the same effect. If it's not working right, it'll shut the thing off. It'll actually stop working. And then the third test is called ESD, or electrostatic discharge, which is close to what he's doing here. And so what'll happen is it looks like a welding iron. And you walk up to the stuff and you just zap it with 2 kV of power of a short pulse, and it'll shut stuff down. And a lot of stuff, the only reason it would shut their computer down is because the network cable, the RJ45 cable, wasn't shielded, because it didn't have shielding on that cable. It would shut everything down. So lesson learned there is, whenever if you got a hardwired network, get the shielded cable.
Yeah.
Yeah, it's interesting. And if you have still, this is something else I used to, especially like late at night when I was playing with lifters, you could kind of see streams of ions. Oops, Wayne, it looks like you've got your screen share going.
Oh, is that me? I don't think that's me.
Here, let me.
Looking at
Who's screen sharing?
There
we go. Yeah, but yeah, late at night, I used to notice you could actually see streams of ions going through the air. You know, you could see how they would affect like cobwebs and stuff like that, right? When it's really still, there's not. Yeah,
especially when it's dry.
They're messy. They're really messy. They get everywhere. Oh, this is Jeremiah.
Yeah, just
no, that's not me. I tried to share my screen, but this isn't me. Sorry.
That's Wayne.
So that's not me.
Okay.
Huh.
No, my screen here is I got this little dome-shaped thruster.
Yeah, that's what we're seeing your screen. What's up?
Yeah. So I'm just editing a video right now where I did some comparisons of some different basic shapes of these thrusters, and soon I just got these superconducting wires. I'm going to be doing some work with that. Different kinds of experiments. So that'll be interesting. Got some.
You're taking on the challenge of making YCBO superconductors.
I got these accelerometers.
Accelerometer. What's that? What's the accelerometer using? Is that?
Well, they're going to plug into an Arduino.
No, I'm just curious what the actual device is. Is it a piezoelectric device or something else?
Oh, probably a MEMS device.
MEMS.
Probably.
Yeah, I've worked with piezoelectric when I had a job at a environmental test lab. That was one of the tests, was a drop test where you'd have to drop it to try and break it.
Problem with piezoelectrics and high voltage is that they can really skew the numbers. It's hard to shield them properly.
Oh yeah, I bet.
Yeah, you know, Mark, Tony was putting in chat that YBCOs are easy to make, and I know Tony's made a bunch of them. He made it. He
made the one for NASA that was 12 inches.
Yeah, and then Tony told me, in fact, he might mention this today when he comes back. I'm not sure where he's at, but he had a theory about the skin on the superconductor. When you make them, when you center them, Tony, do you remember you were telling me a long time ago that there's a skin on the superconductor, and it basically comes from the sintering process. The chemical structure on the outside is different than the crystalline structure on the inside.
I think you're talking about the Bekletnoff impulse experiment, where he said that the gases in the chamber actually got pulled towards the superconductor due to the high voltage and turned into a white cloud. And this white, my theory behind it is that this white cloud turned into a Bose condensate due to proximity effects associated with Josephson junction type effects. And the reason I say that is because he claims that when they discharged the voltage, the white cloud moved it as a single body rather than dispersing, and went and hit the chamber wall and actually damaged the chamber wall.
So is there a difference in the stoichiometry of the crystal structure near the surface of the yttrium barium copper oxide that's different? Is it more or less regular crystalline? I would think because there's skin effects from the high voltage, that there would be a region where the crystal lattice was better. There were less impurities or dislocations in it on the outside than on the inside, kind of like when you temper steel. You know what I mean? When you temper steel, the way you temper steel is you heat it and then you pound on it. And that changes the lattice structure of the steel near the surface.
That was what I had thought that he was telling me, actually. And maybe I misinterpreted it, but.
According to Pakletnov, the superconductor was 2-layered, and then it was melt textured, which means the surface that was exposed to the vacuum chamber and the gases would have been a crystal lattice rather than just a bunch of powdered centered together. But even then, there would be cracks, voids all over the place. These crystals just don't grow as a big single body across a big, large plane. In fact,
it was amorphous crystal. It was an amorphous, like you can buy the old solar cells. They called it amorphous silicon, for example.
If you look up superconductor crystals, is whatever it forms kind of like from the seed they put on there. It forms like a pyramid and a hexagonal shape into the crystal, but the crystal even will grow out. The biggest ones I've seen is about 1 inch in diameter in a hex pattern, but they put a whole bunch of crystals on the surface. So you try to get all these hexagons to form together. So if you do it right, then your whole surface should be at least the density near the density of the crystals, with separation between the hexagon shapes, so it won't be completely a single piece. It'll have some separations in it on the surface.
So I imagine that would affect the efficiency of it, would it not? How good, strong the field is or anything?
It probably does. He also had a magnet on it, so and I'm not going to say how, but if you could repeat his experiment with this white gas, there's actually 2 Nobel Prize type experiments there.
Cool.
But I won't tell you what those are.
That's a secret sauce, huh?
Yeah. Because I will do the experiment at some point.
So that person just showing the video for the superconducting wire, he showed the wire, but he didn't really show the wire. Which wire? What company is he using?
Was that Jeremiah or?
Todd has just sent superconducting wire to. Oh, sorry about that. Let's try that again. Yeah, Todd has just sent some superconducting wire to Wayne, so he now has, I think, 2 different types, maybe some very thin stuff, and it looks like some strip. Its transition temperature, if I remember correctly, is just about 80 to 90 Kelvin. So it's considered a high temperature superconductor. He sent us the charts earlier. See if I can pop those up. If Wayne isn't on, give me just a minute and I'll get back to you.
Well, Jeremiah, I believe the reason Will asked is Will is working with superconductors out in Japan, right? So, I mean, and Will, you're working with a ton. I think you're working with graphene now mostly, right? But
well, actually, we've invented new superconductors, and but we're of course we're a laboratory. So, and yes, we also work with graphene, and we've been doing that for 8 years. But graphene got boring, so we're working with superconductors and stuff, and we're merging graphene and superconductors and stuff like that. So yeah, so
It's BSCCO to answer your question.
Bisco,
RB or REBCO. It's one of those two.
mm-hmm. And do you know the maker? Because there's quite a few makers out there.
I think Wayne had to go, but we'll try to get that info from him. We can get in contact you via email. That would work.
Yeah, that's fine.
Yeah, and be kind to Will. It's I just looked it up. It's 9 a.m. your time now.
Yeah. I've been up since 3 o'clock this morning.
Yeah, I know. That was what I was going to say. It's 9 a.m. Sunday. 9 a.m. Sunday in Japan. So
I don't think my wife would let me get away with that one.
yeah, I've had a few comments lately as well from the better half. Yeah, and I'm not sure where Tony went. He might be looking at some of his superconductor stuff. And then the other thing that he had told me, and I'm trying to think back again, this was over 10 years ago. He'd suggested something about one of the ideas he was working on was that electrons inside of the crystal lattice were going up or down, which might be creating, I don't remember the exact details of it. And again, this might have just been a working theory, but and in that, Tony, do you remember? And again, I could be misinterpreting you. I believe you mentioned once that there were, the way you explained it, it seemed like there were almost like spindles inside of the superconductor, and that electrons, the Cooper pairs, might be going up or down.
The magnetic field forms these magnetic loops in the superconductor, and the resistance through these loops are like those crap, what do you call them? Not the buckyballs, but the carbon loops, where they have no resistance through the center of them. It behaves the same way. So electrons could actually go through those loops through the superconductor faster than the speed of light.
Here, Tony, this is the print plate.
Yeah, it looks like G10. Yeah.
It says PEI on it, and all you gotta do is just bend it, and 3D print just pops right off.
Yeah, what I use too on top of my aluminums, but I use the glue sticks because I still have a problem with it not holding down to that.
What kind of material are you printing though?
It's the same as that, except it's yellow. They call that R something 4, but it's also G10. It's two names. But I use some stuff I bought a long time ago, so it's yellow instead of green. But I have bought some green stuff recently. I do recommend the glue sticks. I can send you the name of the one I use if you want.
I'd appreciate that too. Hot glue is a huge deal for me. Mark will tell you, I've asked him to send me specifically some hot glue sticks he's found, so that would be very.
I'll get one and I'll show it to you.
Yeah, please.
What is the significance? I feel like I've stumbled
This
into
is
a
the secret sauce, right?
Yeah, this is the secret, and it's. But the way he described it, there was something in his eyes. It's like it's like, you know, it's not just it's not just glue. It's yeah. See, and he's like, this is the good stuff.
This comes from made in Germany. It's UAHU.
Can you turn it? There you go. Say something.
Well, if you show my video on the full screen, I could tell what I'm doing.
Got it.
You can see it just fine. Say something.
I'm here, but
No, I can see it. The Uhu stick.
yeah, it's made in Germany, and it has latex in it. Not the reason, but I've used some of the stuff. I forget what the name is that you can buy from Walmart, and it don't work at all.
Yeah, Michael, it's $2.
This actually came with one of the printers I bought, but this is just a bigger stick than what came with the printer.
Are you using green screen?
Yeah, he is. He has, and I forget that too. Tony's green screen is really good, so I keep forgetting that it's a green screen. And then, That's why the Uhu stick was disappearing, because it was trying to backfill.
It looks like a green screen effect.
Yeah.
That's my lab in my back. Yeah, with Zoom I can put a background. So with some of these other video programs I can't, but Zoom I can. I'm in my bedroom. I don't want you seeing my bed and everything there.
No, I don't do one because it clips people's hair and but it's not clipping you. That's the other reason why it looks so good that I forget. And
Pretty close to this monitor. I use a 55-inch TV screen as my monitor, and the camera takes up the viewing screen a little bit. So I set it in the floor. That's the reason I'm not in it sometimes. As long as you can see my screen, I'm still here. Anything else? You were talking, Tim, I think, about the
You
super.
can also use this one too. This is the one I use.
now, so you guys are using those for 3D prints then? You use them to hold the.
Yeah, this is for FDM. So yes. So yeah, as you know, Tim, we have FDM, SLA, ceramic, or just about everything actually.
Well, the reason I asked was I don't 3D print at all, and so when you guys are showing me the glue sticks, is it to hold the print down?
This is hold the print down so that it doesn't move. Sometimes it'll release itself.
Okay.
And of course, this one. Each type is good for different kinds of filaments. So you need the one that matches your filament. So also, if you just buy I found, especially with PLA, the glue sticks that, the ones that you buy in the store for gluing the paper, like, for your envelopes and stuff.
Yeah.
Actually, they're very cheap and they work great. And yeah, I mean, they don't work as great as these because these are, chemically superior. But as a general and low cost way, the other glue sticks are just great. So on our cheaper machines, we tend to use those glue sticks. But these are what we use for our industrial printers.
Interesting. Yeah.
So my wife just came by and she asked me, "Is this what you geeks do on Saturday?"
Well, there's always Star Trek reruns, right? It could go either way, but
I of course was honest.
You have a great wife.
I would be writing a paper in my lab instead of this.
well, no, I appreciate you joining us, though. I appreciate everyone joining us. I mean, the thing, and Mark and I have talked about this so many times, but it's really exciting to have a community forum, right? And it's pretty mellow and laid back and tolerant, and like Michael was saying earlier, right? And that's the whole idea, is so that people can exchange ideas and insights, and that doesn't always lead to anything, but sometimes it leads to brilliant problem solving. So
I see a lot of similarity between the work and even some of the stuff, even what Todd was talking today, kind of related to the paper I want to talk about next time.
Yeah, well, so yeah, and then Tony, you're presenting next week, and Tom Vallone was going to ask Eric Davis, but Eric has been rather quiet lately. So the only person who really hasn't said anything to me in a while is Martin Timar. He's being very quiet, but
I mean, he's not being quiet in the news. He's getting all the headlines, and actually, that's how we ended up on Popular Mechanics, because Robert Scheuer had the opportunity just like 2 days later to respond to that, and that was the rebuttal article from Popular Mechanics on the M drive. That's how we made it up there.
I would love to have Martin attend, though. I know he has created a little bit of friction lately, but at the same time,
Well,
He's-
he's really he really was the first one to stick his neck out. If you think about it, he's he's really a trailblazer in my mind. So
Yeah, yeah. Well, no, he used to go to the STAFE conferences too, so yeah. I mean, yeah, Martin's he's a nice fellow. What I think what changed was, and I'm not positive about this, but when he became a professor, and then they gave him a bunch of students, and his responsibilities changed. And I remember him. This was several years ago. He told me when this changed, he had almost no free time for experiments, and everything that he was able to do, he had to do with the students, right? So that he could kind of couch it in those terms. So that's my understanding, but.
gotcha. He became more of a bureaucrat.
That's a pretty typical professor thing, which is why I have had to turn it down. So
well, that's why I used that cartoon in my presentation about the doesn't matter.
Yeah.
My opinion is the professors who are worried about tenure will not come out and say stuff like this is real. It will always be false. And I'm worried that Timor might be put in that same situation.
Well, I would think that applies to people in the government equally. And there's lots of trailblazers in the government that we don't hear about what happened until they retire.
Yeah.
They can actually talk about it. So it goes back to that reward punishment thing I was telling you about. It's not about our well-being. It's about who's correct.
The exception to that is UAPs, though, and this is just in the last year where we've gone from having an iron curtain where the government won't reveal anything to now they're in the news saying, "Oh my God, please help," which is actually in a weird way more terrifying.
Well, no, we are. That's what we're doing, and I think they're afraid because of, like I said, it's a cultural thing. We don't understand that this is, it's not normal to just always be everything that's based on violence.
Well, it's interesting too, and I'm sure Tony could speak to this at NASA. Dennis Bushnell also has spoken to me a bit about this. NASA has a lot of cultural stuff too. And one of the things that I've been hearing lately was how NASA has learned to accept like the SpaceX model, right? And I guess my understanding was there was a lot of pushback against that. And now there's more acceptance, and
right. And
so
it's better for all of us because it's through the commercialization of this space that we're actually not just getting better stuff, but we're getting stuff that costs less.
Well, the other part too is, I mean, the area where this is just my personal opinion, but the area where NASA really shines is with the rover program. I've just been so impressed by that, and then if you look up there was the Spirit and Opportunity rovers. I wrote a story about one of those last year. You look up mission life expectancy and equipment and component life expectancy on that. They exceeded the life expectancy of those rovers 55 times over. They planned the mission. They said this rover will last about 2 years. I think it was, what was it, going on like 16 or something like that. So
yeah, but can we still make stuff as good today as they did back then? When we look at the products that we buy today,
but
they're not as near good a quality as that stuff back then. I mean, it was slower.
I like the new rover though, and rover is a misnomer. If you look up the dimensions, because I was like, oh, look at that, they're doing a new rover, that's cool, it's gonna, they're gonna land this new rover, right, the one with the helicopter, Perseverance,
right?
But then when you look up the dimensions, it's not really a rover, it's more like a monster truck, which makes it even cooler. It's a nuclear powered monster truck. The thing is, like, it's 12 feet long. The tires are like a foot in diameter each. And I'm like, that's not really a rover. I was like, you could literally run Martians over with that. That's what makes it awesome. So
Well, maybe that's what they're doing.
it could be. That's right.
I mean, Death Race 2000, right? On Mars.
Yeah. So I like Perseverance, and then the camera kit too. And I'm not sure what the mission expectancy is for that, but they've got like a 3-sensor system looking for signs of ancient life. And what was it? One of them, if I remember right, it can look for stuff like methane signatures in rock. It can do it from a distance with a camera, and then they can go up close and sample it and break it down. And so just in terms of that I love what NASA is doing with robotics. That's amazing,
Yeah, Mars has some pretty cool geology. I mean, it's something pretty big smacked into Mars to destroy its magnetic field. And there's some, but I don't see how we could ever have a life on Mars. It's pretty damn cold and dry there. And unless it was 1 billion years ago or something, I don't know. It seems a little unhuman to think about being.
Well,
there.
you make a good point. I lived in Phoenix for a year, and
Yeah.
and the thing about Mars is it's going to be cool for about 10 minutes. You touch down and you're like, I'm on Mars, and 10 minutes later they're going to realize I'm in the middle of a giant airless desert, and I'm going to be stuck here for 2 years.
Well, yeah, but you see, that's only if the I seen this very interesting picture, and it showed the Martian lander, and then it showed the big screen being held up by 2 aliens, showing the desert in the screen.
Oh yeah, yeah.
I thought that was really cool. So,
well, I'm actually really excited by the lunar program too, and I think the reason there is just because we have more staying power, right? We're able to go there and stay, and we're able to do stuff, mine helium-3. Ed McCullough, who used to run the section E of the STAFE conference, he did a breakdown, and he said something like, there's enough free hydrogen trapped in the lunar regolith that for large portions of the moon's surface, number one, you can pull helium-3 out, but number two, for large areas of the moon's surface, you can literally just heat up the regolith and water will come out, or at least that was his belief.
Oh,
yeah, there's a lot of NASA reports on that.
Here's the result of the 3D print. Basically, these are little wedges that I could stick in here on all 4 sides, and it allows me to change the shape of the chamber ever so slightly, just by changing the inner piece, and I can still use that same outer ring and change the shape of the chamber. So that's how that design's going so far.
So this is your waveguide, right?
This is the waveguide chamber. This is where the experiment is going to take place for the C-band experiment.
And the size of that matches your C-band?
It's C-band uses I think it's W137 waveguide, so this is quite a bit larger than that. It's going to be the tuned cavity where the sample sits, and we need to make sure that it's tuned properly. So that's why this is.
Okay. Cool.
Now we're just printing a second one. It should be ready in 3 hours.
No, that is interesting.
Looking forward to seeing your outcome.
So am I. Been at it for quite a while.
So it's good when an experiment starts to come together, isn't it? Starts to feel really, really good, especially if you're waiting for a while.
Especially when there's a lot of components, and the possibilities from this experiment is basically a new state of matter. It'll change life as we know it if it works.
I wanted to show you this crustal magnetism in Mars. that I'm kind of was talking about earlier, that I think something must have hit Mars to really mess it up. Those are actually this is Mars crustal magnetism from the Mars Global Surveyor. And you can see this region that's circled here. That's something happened to the South Pole of Mars that created these features, which interesting. That's what it looks like on the surface of your hard drive. If you're looking at the magnetic domains, that's what they look like. Just like, so it's like something hit Mars and just messed with its magnetic field, and it got permanently stuck in that like that.
So would it be somewhat accurate to say that it maybe almost like degaussed Mars? Would that be?
Exactly. Good. That's exactly what it looks like. Something degaussed Mars.
Because if you have now, I know on Earth, right? Our magnetic field comes from the dynamo inside the Earth, or at least, but Mars is more solid, and so their magnetic field. So like anything that's magnetized, if you shock it hard enough, you can degauss it, right? You can
right. But well, for example, in archaeology, there's this one dating technique. It's called geomagnetic dating, and what happens is some tribes have this practice of breaking rocks. They'd get these cobbles and they'd go on these what were called the salt song trails. They go between Utah, California, and Arizona, and they would like go on these pilgrimages, and they would along the trail they'd break rocks, and they could go back and look at those rocks, and because when they broke, they basically erased the magnetic field on the rock and locked it into time when it was broken. And so they could go back and look at the pieces of rocks on the surface and then trace back the Earth's magnetic field and how it processed. And they could say, oh, this is from 250 years ago, or this is from 1,000 years ago. And so essentially it's what you're talking about. But in this case, it got locked into place. So it was like, so what I think happened is that sometime in the past, Mars was like Earth, and it had a protective magnet. So our Earth's magnetic field actually protects we have an atmosphere because of that magnetic field. Life's here because without that magnetic field, the heavy radiation from the sun would have probably made life impossible. So it's a protective shield. It creates a protective shield around the planet Earth. Apparently, that was the case in Mars too. But at some point in the past, that went away. And it seems like it's related to volcanism, like our Earth has molten, it's called volcanoes. It's got a shell on the outside and it's basically liquid, superfluid, whatever. But that's not the case for Mars anymore. Mars doesn't have a magnetic field like the Earth. Something happened. And that's why I wanted to show you guys this image.
Well, and that's interesting. I mean, so on Earth, and I remember I interviewed Tom Van Flandern, and at this time, this was 2004, I think. And back at that time, this idea that the Earth the moon was created by an asteroid impact or a planetary impact.
Yeah.
That was way out there back then, right? He was fighting against the power. I don't remember when that was accepted, but now I guess that's supposed to be the prevailing wisdom. And so
no, actually, there's people that think it's not true because they think the moon is the structure, the composition of the moon rocks are so much similar to Earth. But what's wrong with that thought is the actual evidence is that the outer part of the Earth, the crust, is extraterrestrial in source, that it came from outside, and that there's an inner part of the Earth. And the way that they can prove this is using helium gas. There's different isotopes of helium gas at a certain level. They go to a certain depth, and there's this helium well, I think it's in Australia, where they did isotope analysis on the helium, and they find more of, they find the type of rock that they have in the moon is more like the outer crust part of the Earth.
Okay, yeah.
So the moon, yeah, maybe the moon got spit out when this collision occurred, but there was a proto-Earth, in other words.
Exactly. Yeah. Well, and then I think complicating things further also is what is it? The Earth and probably the moon also pick up, was it hundreds of millions of tons of space dust every year, right?
Oh yeah.
And that's been going on for billions of years. And so I'm not sure how much that adds up to, but it's probably a lot.
Well, our Earth, there's reason to believe our Earth's gravitational field has changed over time, because, there were periods when we had gigantic animals like the dinosaur age, where huge critters were growing that I don't think they could work nowadays. You know what I mean? So the gravitational field, and also the rotational time has changed over time.
Yeah, I know the rotation is slowed a little bit, if I remember right.
That's not constant is the point.
Yeah. There's been some change.
Okay, thanks for letting me share that.
Oh, sure thing. Well, here,
he was just confirmed by his cousin on Facebook that he did pass away.
Wait, did she confirm it, or was she just responding to your post? Because I saw that as well.
There was another post on his page that from a cousin of his that he actually did pass away, and that what you just brought up over there sort of reminded me of Mark, because he was very big into the war on Mars theory.
Oh, and cool.
If everyone has a glass, we can raise a glass to Mark McCandlish. You guys have something to drink? Okay, to Mark.
Okay, yeah, I will raise a glass to Mark.
To Mark.
Well, he certainly did pioneering work in the UFO UAP area. I mean, he was an aerospace illustrator, right? And he did tons of aerospace illustrations, and a lot of those I don't think ever got the recognition that they deserved. But I mean, I think that he really staked his claim in terms of UFOs, so.
Does anybody know how old he was?
68. 68.
Oh, wow.
That's a lot of what happened, but he was 68 years old.
Yeah, and he was very active too. He was still working. I think he was doing volunteer work at an animal rescue shelter, and
He was on a conference in October or November it was. Last year. Did a very nice presentation, and it's great that we had APEC together, so he was able to give one more presentation about. I think he presented on stuff that he's never presented before here.
Well, and that's for me, that's one of the things that's exciting is trying to capture some of the legacy, right? Is trying to capture, the legacy of ideas, because this community generates so much information, and I mean, it's also a tragedy.
This lost a lot of information. So much has been lost by people who didn't talk out. It's glad that we had Mark to come on and share that information while he was still with us. And it just shows everyone that life is short, and it's important that he was here and shared that with us, man. That's awesome that we got that interview.
Yeah, and there have been several, lots of folks in our community, I think, that we've lost, but
so I actually got a shut. I have to go. I have a friend here who wants to be fed.
Oh yeah, that time of the.
So and I had fun. I appreciate it. Thanks for having me, guys.
Well, thank you,
Hey, Michael.
Michael.
Michael, I just wanted to say something. Michael,
Hey, they discovered a shark fossil here right outside of Albuquerque, New Mexico, and they call it the Godzilla shark. It was a news story last night.
And it was huge, right? It was like a 6-inch shark's tooth or something like that.
They call it the Godzilla shark, and I didn't hear it. It was either 7 feet long or it was 70 feet long.
I think it was 70.
Really?
Yeah, 70.
I thought you might like that.
Normal. Great whites are 7.
Yeah.
Oh, okay. This is what they call a Godzilla shark.
Some of that could be related to the I don't remember what they call it, but the nuclear winter that happened after the impact. Because from one of the things I'd read was there may have been some gravitational changes, but I also read that supporting that much body mass, right, it takes a lot of food, and for like thousands, hundreds of thousands of years, basically all life was scavengers. So all those heavy body weight animals died out. They just couldn't maintain that much body mass.
Right. And the food. So the point is, though, in the past, there was more abundance than there is now. A lot more.
Yeah. Yeah.
So I got to go though. Thanks again, folks.
Thanks again, Mike. Have a great day.
So you said Mark McCandlish was 68. Is that what the age was?
That's what it said in the obituary website.
Well, yeah, we will definitely remember his legacy, and I'm glad he was able to join us on the conference. And I think he contributed a lot to, to this community, to the UFO community. He contributed a lot. So he was busy. He was on Coast to Coast AM quite frequently, as I remember. He was a busy person. And I think he changed a lot of lives, and he was doing volunteer work. And what I know is he touched the lives of people around him in a big way too, right? He was a very caring person. He had a lot of personal friends that he was helping, so it wasn't just publicity. It wasn't just UFOs. He was actually trying to change lives, in front of him. So that's a good thing.
I got a couple emails from him. I was just looking back, mostly through Facebook, going over like all the details on the experiments that I was running. And he really took a lot of time out of his day in order to communicate with us and work on all that stuff. And he put together a sick ass presentation for APEC, and really appreciate that. And, catching that legacy was key. Who knows what happened? We haven't heard yet what happened to him, but I'm sure we'll hear in the coming days what happened.
Yeah. Well, so do you guys, should we wrap things up for today then, do you think?
Yes.
That's my child. Did you hear that? You heard? Yeah, I have my mic open. That's my 11-year-old. She wants to video chat with her friends.
Getting ideas from her dad.
I guess that means it's time to wrap it up.
Yeah. Okay. Well, thank you all for joining us. You guys have a great evening then. And
Thank you. Thank you. Good night.
Good night.
I got someone else who wants to be fed too.
Okay. Have a great evening, guys.
Take it easy.